Hi. Hi. Today we are going to discuss about Davisson and Germer experiment. This experiment supports the concept of the duality. De Broglie hypothesis given theoretical explanation for dual nature of the light, and experimental evidence is given by Davisson and Germer for the concept of the dual nature of the particles. In this experiment, we have an electron gun is there. So that electron gun, or that will be called as a cathode. It is connected to a low tension battery. And in front of electron gun, we have slits. These slits are connected to the battery terminal, battery positive terminal. And where high tension battery is connected to the slits and low tension battery is connected to a coil that will act like electron gun. In front of these slits, we have a target material. In this case, the target material is a Ni, and we have a circular scale. On the circular scale, we have an electron detector. That electron detector, another terminal is connected to the galvanometer. Galvanometer, one of the terminal is connected to the ground. So this is the experimental setup. When the battery is in on condition, the filament get the temperature. Because of the temperature effect, it emits the electrons. This is occurring because of thermionic emission. So electrons will be released. Electrons will be released through the electron detector, electron gun. But the emitted electrons acceleration is very less. For these electrons, it is very difficult to propagate up to the target material. Therefore, in front of electron detector, we have a slit is there. 3 slits are there. These slits are connected to the positive terminal of the battery. So the significance of these slits are they accelerate the electrons towards the target material side. So when they are propagating through the slit, we will get a fine beam of electrons at the outside of the slit. This fine beam of electrons, they are now interacting with the target material. So the fine beam of electrons are called as the primary electrons. Primary electrons are nothing but these electrons are came from the electron gun, or which electrons are emitted by the electron gun, that is will be called as the primary electrons. Now they are coming with a good acceleration and they are colliding with the target material, and when it is bombarding the target material also emit the electrons. So these electrons are called as secondary electrons. So initially we have primary electrons only, We have only primary electrons are there. But after the interaction, the electrons are diffracted in different directions towards the circular scale side, and where we have primary electrons as well as secondary electrons. The primary and secondary electrons, they are coming towards the circular scale side. So it means that they are diffracted in different directions towards the circular scale. The primary and secondary electrons are diffracted towards the circular scale. On the circular scale, we have electron detector. That electron detector will detect the only primary electrons, and it cannot detect the secondary electrons, because at the entrance of the electron detector, it having two walls, the two walls having certain potential difference. So that potential difference allows the only primary electrons, and it cannot allow the secondary electrons. So whenever the secondary electrons is coming towards the electron detector side, it will be reflected. Secondary electrons will be reflected. But whenever the primary electron is coming towards the electron detector, so it allows the primary electrons. So these electrons will be propagated towards the ground side through the galvanometer. And this electron detector will place at the different positions on the circular scale. And we will monitor the current in the galvanometer. Based on these readings, if we draw a graph, intensity, this is intensity, y-axis will indicate intensity of the current, and x-axis will represent the angle. So it is observed that at a theta is equal to 50 degrees, we observed that the maximum intensity was observed at theta is equal to 50 degrees. At the applied voltage is 54. Using this data, now we are calculating diffracted angle. So in this case, the maximum intensity is observed at theta is equal to 50 degrees. So you just assume that this is the surface of a target material. So light is incidenting on that, and it is reflecting back with where we are assuming that is called phi is equal to 50. Now we want to calculate the diffracted angle. So for that purpose, we are calculating diffracted angle. So this will be equivalent to 65 degrees. Using this data, we are substituting in the Bragg's law, that is 2d sin theta is equal to n lambda, where d is the interatomic spacing and n is the order of the diffraction. For the Ni crystal, the d value is known value, that is 0.91 Armstrongs, and we observed the first order diffraction only, so small n is equal to 1. So now we are substituting d value and n value and theta value in Bragg's law, that is 2d sin theta is equal to n lambda. So according to that, lambda is equal to 2 into 0.91 Armstrong into sin 65. So the calculated lambda value is 1.65 Armstrong units. From this experiment, we are calculated the wavelength of the electrons, that is 1.65 Armstrong units. Now this experimental value we are comparing with the theoretical value using de Broglie hypothesis. So according to de Broglie, lambda is equal to 12.26 by root V. And in this case, we observed maximum intensity when V is equal to 54 volts. So now substituting that value in this equation, V is equal to 54 volts. So then the value is, the calculated value is lambda is equal to 1.67. So this will be the theoretical value. The experimental value is 1.65 Armstrong units, and experimental value that is, and the theoretical value is 1.67. They are good agreement to each other. So it indicates that this experiment successfully explains the dual nature of the particles. Thank you.